After understanding the CES production function, now we'll talk about the isoquants of it and definitely its slope. We will try to judge about its forms, that is, you can have a glimpse of it. So let us get started, and before we do, I suggest that you subscribe so that you get more of this information, which is going to be helpful in innovative ways, where you will learn about softwares and quantitative aspects of economics and also other research tools. So this is the formula of slope of isoquant that we developed in our last video, where we calculated the elasticity of substitution of CES production function. Now if we shed some light on it, this is the formula actually, that is 1 minus delta is there in the numerator. If we talk about numerator, that is the term parameter, that is delta. Delta is basically a value between 0 and 1, and when we subtract it from 1, it will also be between 0 and 1. For example, if it is 0.4, the answer will be of 1 minus delta, it will be 0.6. If it is 0.5, the answer of 1 minus delta will be 0.5. So you see, it will remain between 1 and 0 if it is itself between 0 and 1. So we have a positive value no matter between 0 and 1 in the numerator, and delta it also has been understood to be between 0 and 1 and a positive value. Then we have capital and labor. Both of them are inputs that are non-negative, that is either 0 or positive. So there is a par, and again the par is there, that is rho plus 1, and when we solve this with this base, we are going to get some positive answer. Now this negative answer in the end is going to make this positive answer negative. It means that the magnitude was positive, however the negative sign outside is going to make it negative. It means that we have a downward sloping isoquant, which is the basic feature of the isoquant. So we have been assured that we are going to have a negatively sloped curve, which is suitable for the isoquants. Now this term, that is capital to labor ratio, is the critical term, because this is the ratio between capital and labor. It determines the change between labor and capital, the substitution, and hence it also determines the slope of the CES isoquant. And when we make array, and array is basically the ratio of capital and labor, which is fixed, because when we make a array, it is going to remain the same, the ratio between the labor and capital across all the isoquants, as we have seen in the diagrams. When we do this, it is going to retain the slope of the isoquants at all the points of intersection, and when this happens, we say that the given function is homothetic, and here CES production function is being discussed. So it means that CES production function is homothetic. Now the values are taken of rho and the sigma, and by using the formula. For example, if the value of rho is -1, 0 and infinity, these are three extreme values, two extreme values and one value in the middle. As we remember, the range of rho, it started from -1 and it can go to infinity. So somewhere in the middle there is 0, so we chose this value. Now we put these values into the formula of elasticity of substitution, which was 1 over rho plus 1 that we developed in the last video. You can refer back to it if you want to. And then we put the values, that is -1 here. Here you can see -1 is substituted. In this case 0 is substituted, and in this case infinity is substituted. Then we can solve them, and it is easy to solve. Then we get the values of sigma. In first case it is infinity, other case gives us 1, and in the third case we get 0. So when there is infinity as the elasticity of substitution, it means that substitution is as possible, as maximum as possible, that is they are perfect substitutes. And when the elasticity of substitution is 0, it means that they cannot be substituted and we have perfect complements, that is there is no possibility of substitution. And if it is equal to 1, it is somewhere in the middle, which is known as the Cobb-Douglas inputs. And this is that case that we usually study, because the elasticity of substitution of Cobb-Douglas production function is equal to 1. We have studied this before, developed it, and here this thing is getting verified. Now this is the set of possibilities that lie between under the shadow or umbrella of CES production function. So you see, Cobb-Douglas production function becomes one of the possibilities, and CES production function is a general category that also includes the possibility of perfect substitute inputs and perfect complement inputs. Now let's gather all these possibilities and even more. You can see that we have plotted capital and labor, and we are having a view of the isoquants. Let's start with the first isoquant. This is basically a map in which we have gathered more than one isoquants of different nature, not the same nature, because when we make the isoquant map, it is usually the isoquants of the same nature. But here we have the first isoquant. Let us say that it is represented by capital A, the second one with capital B, then C and D and E. The elasticity of substitution of the first isoquant is 0, and it is this L-shaped isoquant. The perfect complements, which is also known as the Leontief input system, in which there is no substitution possible. We have perfect complements. Then we have the other extreme, which is the isoquant E. It is a straight line, and it shows that there is perfect substitution between the two inputs. And here the elasticity of substitution is infinity. Definitely it means that there is no barrier, and we can effortlessly substitute the capital and labor. Now in between we have value of 1, a value of elasticity of substitution as 1, which is represented by C, and here we have this curve. This is more like the Cobb-Douglas production function isoquant, and this is the same case. We have been making this usually. Now in addition to these two or three cases, we can also consider this case between these two cases, and this case with a lighter color between these two cases, because definitely there is a possibility of having cases between these two cases or these two cases. So between the Cobb-Douglas and Leontief isoquants, we choose another possibility where the elasticity substitution is nearly equal to 0 but not equal to 0. It is represented by B, and you can see it is close to the perfect complements case. So it is quite a bit like the same the Leontief production function, but still not exactly a vertex is there. So there is a little bit of possibility of the substitution. Now we consider this case, which is between the Cobb-Douglas and the perfect substitute case. It is equal to it's having a value of elasticity of substitution equal to 5, and it is greater than 1, and it is closer to infinity to a certain extent, but not exactly, because infinity can be any value, but it is in between the value of 1 and infinity, somewhere there. And you can see that it is having this inclination towards the straight line, but it is in between the Cobb-Douglas and the perfect substitute, which is a straight line actually. Now we have tabulated all of them so that it becomes easy to remember. This is the isoquant A, B, C, D, E. This is the nature of inputs. This is the row value and the value of elasticity substitution, that is sigma. So at A it was 0, that is the sigma value. In the background of it, the row will be equal to infinity. You can check it from this table and you can try to calculate it on your own. And if the Cobb-Douglas case is discussed, then the sigma is 1 and the background row will be 1. And in case of perfect substitutes, the value of sigma is infinity and in the background the value of row will be -1. So you can refer to this diagram, and these are the two cases that are in between, where the elasticity substitution is 0.1. So in the background the value of row is 9. You can calculate the value of row if you know the value of sigma. It is very simple because of the formula, which is equal to row is equal to 1 over 1 plus row. Sigma is equal to 1 over row plus 1. And this is less elastic isoquant. Here you can see it is less elastic, the elasticity of substitution we are talking about. And in this case, if sigma is 5, it will be -0.8. You can also calculate it by pausing the video. And it is highly elastic isoquant. It means that quite a bit of substitution is possible in this case, because it is closer to the perfect substitutes. So in this way we have thoroughly understood the isoquants of the CES production function, and we see that Cobb-Douglas production function is just one of the cases of the CES production function, and there is a number of possibilities between the two extremes of Leontief input production function and the perfect substitute situation of the production functions. Thank you.